at the sides assembled. Basically, so far the assembly process has been loosely assemble the cube and these two sides, and then you mount the steppers. Then you put these shafts mounted on with the sleeve bearings at the supporting angles here, and then you kind of align it right so that it's perfectly perpendicular to the axis. Well, so far as you can tell, right? And then you hand tighten these screws, and that's what I'm doing right now. So it's good progress. Like I thought I made an alignment error somewhere in the manufacturing process, but I guess it hasn't come out yet. And if so, that's good because this is a major component, and the other parts are more easily replaceable.
More parts here. What are the challenges so far?
The real challenges are just streamlining the manufacturing process and having one that ensures proper alignment. Alignment is the major factor, and I discovered that like the flip template that I used, actually I'll show you. Essentially for this, I used 3 templates. I began by fabricating a perpendicular alignment template, which ensures that all holes drilled are 20 millimeters from this edge perpendicular down, such that, say, if I have a bar here, right, and I put this perpendicular alignment template on top of it, then all of these holes become, well, actually, it's supposed to be like this. All of these holes become 20 millimeters right from the edge as I drill through that hole.
Okay.
It ensures perpendicular alignment. And then this is the parallel alignment template, which ensures that along the parallel to the bar, you have the correct lengths for each of these pieces. And then finally, what I needed to do was make, as you can see, there are these angle holes, right? So you want an angled alignment template, and you actually want it so that, I did the math on this, if you want a proper triangle corner like this, you need the, if you go here, you need the distance between that, like that hole and this hole, along, like parallel to the bar, which is right now 40 millimeters, to be double the distance between this hole and the inner edge of this angle. So here, parallel along the angle is 40 millimeters, and here is 20 millimeters, such as this is also 20 millimeters. So
okay, so details. So you've got 3 little jigs for.
Oh yeah, I should explain the angle one. So the angle one was more difficult to make because I had to first drill a hole that would become the reference when I was drilling. So hence this hole, actually I would put a M2.5 screw into here, and then I would kind of like do that so that the hole would refer to the angle hole here. Then somehow I had to move 40 millimeters, mark it here, and then transfer that mark onto the other side here. And now, after you put the hole through here, you have to transfer this line here. But I found that if you just use a combination square, it's not, like, it takes too much time, and you have to fiddle down to it too much. So I decided, why not just place a bar like this, and you forget about the combination square. This is your combination square, and you mark it, and it's much faster. But after doing this, I discovered a better way to ensure more accuracy, because I found by using this angle template, I had to, as opposed to these templates, which I just drilled through the holes, I had to actually remark these angle holes and then position it right while I was drilling. So, remove this angle template, and instead of referring from holes, I'm now going to just go for referring from datum edges. That is, what I was doing is have a reference hole here, and each other hole is a particular length away from that. So for instance, this is 8 millimeters away from this reference hole. That is 16 millimeters away from this reference hole. That is 70, that is 170. So it was all from this reference hole, but now if you do it from the edge, what I can do is, say I have a particular angle, I just align the datum edge to the workpiece edge, and then I drill through the holes. Then I clamp it and then I drill through the holes. And now, because I do that, instead of referring from a hole and having to use this angle template, I can just refer to the edge again and have proper angular alignment, proper alignment from these two angle holes without the use of an angle template itself. Because I was always running on the assumption that if I'm going to refer from an angle, if I'm going to refer from one hole and then go 90 degrees and then try to make another hole there, I always need an angle template. But once I got rid of that assumption, I found this and...
Okay, so there's some significant technical details in alignment.
Yeah.
We'll document that elsewhere. And for now, so how long did it take you to build this frame so far? I mean, say you had the technique worked out. How long did it take you to work out the technique so far? I mean, you spent a few days on that, right?
Oh, yeah.
Uh-huh. And then once you have it, how long does it take you to actually build this structure here?
If the technique's worked down, the materials and tools are all there, then less than 2 days.
Less than 2 days?
Yeah, less than 2 days.
Including cutting, or?
Including cutting. Cutting was easy because you don't have to worry about the lengths. You just do it roughly.
So this entire structure, what you have so far, would be about 2 days to align and make. Yeah. Okay, that's good. All right. What are the next steps?
The next steps is, well, actually, get some more screws because I ran out of my M5 screws. But also just continue on this assembly process and see all the problems that might arise and fix them.
Okay. What's the estimated time of arrival for a circuit mill that actually can etch its first circuits? You've got the electronics, right?
I've got the electronics. I don't have the G-code software, like that system worked out. But I do have GCTR operational. So excluding the G-code system, I think it really depends on when the lathe is gonna come, because that
it's here. I'm picking that up today. Yep.
All right. Okay. So if the lathe is here, then I have to wait for the coming of the screws again. So based on from last time, I'd say under a week and a few days.
Okay. So almost at the end of early February. We're going to start milling circuits. Good. Okay, good progress.